So now let's come to the practical part of the video. So now we are going to decode the SSB signal to get the MIB. Okay, so let me just make you understand the pipeline. So first step, what we are going to do is we are going to generate a SSB contained recording. So this recording contains a phone that received SSB signal. This recording contains this SSB. So since we are using the 5G toolbox, we can just call it using the function called wavegen. So this function gives me the recording that has been received by the cell phone antenna. Yeah, more like a simulation only still, but which contains the SSB. Then we generate a PSS sequence using NRPSS. Here the NR means new radio, which is called for 5G. For 4G it's called LTE, and for 5G it is NR. So using this, just as I told the theory, NRPSS gives you the known PSS sequence that is fed during the manufacturing part of the phone. So now this wavegen contains the PSS, SSS, PBCH. So we compare this both using correlation and get NID2. So using NRSSS, we generate another set of known that is already fed into the mobile phone manufactured, and we correlate with the received SSS to find NID1. Then we decode this PVCH using NR PVCH in decode, a function that is used to, okay, since it's a function, I need to put bracket here. So this function decodes the PBCH from the wavegen. So I have just allocated this wavegen into variable called Rx. So Rx is compared with PSS to get NID2, and this Rx is just compared again with the SSS to get the NID1, and again this Rx is compared with, the Rx is fed into the decode to get the PBCH. So this is a simple flow. Now let's see it how it works in MATLAB. Okay, now let's talk about wavegen. I told about function, right? It contains the PSS and SSS and PBCH with DMRS, of course. So it has all these value fed into the function, and then we call it. We not just call it, we have a gap. So we use a carrier spacing of 30 megahertz with a SNR of 50 dB. Okay, so that is the first part of the MATLAB code. We define the SSB space to be like 30, and then defining the wavegen with those both parameters and saving into the waveform. Got it? So now we just save it into Rx, just as I told in the flow. Where is the Rx? Yeah, here it is. Just defining the variable. So let me just copy paste to see how this graph is. Here you can see. So in theory, I told you like radio tower transmits the SSB with periodically with a gap, right? So this is the gap I've been talking about, and this is the subcarrier gap. So this is how the SSB is transmitted by the radio tower. Okay. Now let's go to the, now just comment it out and comment out that out. Now we create three PSS sequence. I told, right? NID 2, 1, comma 2, comma 3. So three possible sequence. So that is what is being defined here. And I'm creating the sequence using PSS. So this is the known sequence that is it's been fed during manufacturing. And then we correlate it with Rx. If you notice, we correlate with Rx and PSS 0. And then we plot it. So I will share this code so you can look at yourself and how this timing offset is being played here. So I don't want to make the video complex, so I'm just saying the outer layer of it. So the same thing happens. The PSS is being correlated with the known sequence, and the SSS is being correlated with the known sequence. You can see SSS and RX, and it is saved into NID1, and that is saved into NID2. And then we find the N cell ID, which is also called PCI, physical cell ID. So let us see what value it is. We can see it's 815. In the example part, you might see like 1008. Why? Because the NNE1 here is 2 270, not 336. So that's where the change is. So since this comes under OFDM, we demodulate the signal to get the even more accurate data for PVCH. Now we use the inbuilt function called PVCH incidences, and we extract it to find the PVCH symbol. Using this symbol, we find the MIB. So I've told you about the DMRS, right? So the y of k, which is equal to h of k dot x of k. So the PVCH symbol is what is called as x of k. To find that, the DMRS has happened in the PVCH decode to find the PVCH bits. So and then we use this to find the MIB. So let me run the whole code and get to see what is MIB. So MIB, this is the MIB's value. This just consists of zeros and one. So this will be known by the phone and decodes the system information. And this is the directed PCI. You might note it here. So these are the reference I've used to generate this code. So this is the reference that talks about the PSS symbol, and this function used to generate an SS symbol, and decode is used to decode the PVCH modulation symbol. So to use the demodulation, we need symbol, right? So that is the reason we extract the resource. We use this function nr extract resource, which decodes this symbol from the indices. So let me show you the values of indices so you might understand what I'm trying to say. So this is the value, and using this I just got to find the symbol. Let me show you the symbol. So this is what we needed. So indices is the serial values of the every PVCH that is exist. And then since we decode the OFDM here, we use NR OFDM demodulate, we get the RX grid. So using this both values, we use the extract resource and we call this function into it and we get this complex value. And then we plot and we get the MIB. So this is how this thing works here. So I'll attach all these reference app to, and you can see the link for this GitHub page in the description. So this is a simple thing, but the terms and the things to understand is a little complicated. That's why I hope you understand, and thank you.